Hey everyone, this section is video is gonna be over adding expressions. In one textbook, they're called adding algebraic expressions, and one it's called linear. Either word is the similar thing. So we're gonna add expressions. Remember, expressions are math problems that don't have an equal sign. So we have to look for our like terms and then add together any like terms. So what is a term? First of all, let me give you an example of something. What if I have minus 5x plus y plus 2? So this is an expression. There's no equal sign. This is my first example. And it has 1, 2, 3 terms. So a term is between each plus and minus sign. And you can have variables, numbers, and they can be times or divided, but anytime you add, it turns into another term. So 3 terms are here, and a number can be a term also. So how many terms would I have if I just have the number 10? Well, it's just one term. And it's a constant. We call it a constant because it's just a number. 2 is a constant as well. It's just a number. It doesn't have like an x with it. This is also still a term, even if I had the x. Now, this isn't a constant because it has the x. A constant means it stays the same. We don't know what x is, so this could be, it could change. So this is a monomial, one term. How many terms would I have if I have 5x's minus 5? How many terms do I have there? 1, 2. 2 terms. Okay, again, that constant is not typically, a term without a variable is a constant. So we could write that definition out. It's a number. So they call it a term without a variable. But I like to say, well, it's a number, right? So constant's a number. The other word is the coefficient that you're going to hear. So we heard the word term, and term I can't really define, just to show you examples. But coefficient is the number in front of the letter, or so it is the number, yeah, multiplied is a better word, by the variable. So let's look at some coefficients. I'm going to go back up to my examples. We know this has 3 terms. What is the coefficient of my first term? What is the number in front of the x? It's a -5. That's our coefficient, -5, in the first term. The second term has a separate coefficient. They're not the same. What is the number in front of y when I don't write one? Well, I'm really lazy. Math people are lazy. We have a symbol for everything, right? That means a 1. So the coefficient in front of that y is a 1. This one's a constant, so we don't have a coefficient because it doesn't have a letter. So what is the coefficient if this is 10x? 10. It's only one term, only has one coefficient. What is the coefficient of the first term? 5. Okay. And I could have, let me do one more example. I could have 2x squared y. This is, this is one term, 2x squared y. There's no plus or minus, and 2 is the coefficient. So you don't have to have just one letter. Typically in the 7th grade and 7th grade accelerated, you're only having one letter. But I'm going to point out you might have more than one letter. All right, so these are kind of our definitions and our terms that we have. Terms, I said terms after we talked about terms, constants, coefficients. Now let's look at some examples from all of this. Let's say we want to add some things together that have like terms. So I'm going to restart. So we're going to add like terms. So remember, the like terms have the same variables. with the same exponents. And I guess I should have said subtract or either one. So add or subtract, we have to have like terms and they have to have the same variables with the same exponent. So what do I mean by that? So here's my examples of the add subtract. What if I have 2x's and I'd like to add to it 7x's? What am I saying? Well, we don't know what x is, but we know in this problem, x has to be the same as here and here because it's the same problem. It doesn't necessarily mean it's the same problem if I have another x in my next example. But anyway, if I have 2 of them and I want to add 7 of them, I add the coefficient and keep the letters. So the coefficients are 2 plus 7, which is 9, and then keep the x. So it makes sense. If I have 2 x's, I don't know what they are, plus 7, I have 9 of them. So that's our like terms. I could split that up. Maybe I have 3x minus 4 plus 7x minus x. So here is getting a little bit harder. I have 1, 2, 3, 4 terms. The coefficient on this first one's a 3, right? And the coefficient on this other x is a 7, and the coefficient on this one's a 1. So if we think about this, we have 3 like terms that we can combine together to make the problem more condensed. So we're going to take 3x and 7x and combine them. I can't combine 4 because it doesn't have an x. That's what I mean by like terms. Negative 4 or minus 4 is not a like term. So 7 plus 3 is 10 x's, and I still have that minus 4, and I still have that minus x. Now these terms are like terms too. So what's 10x minus 1x? Well, that's going to give me 9x minus 4. Now, I have combined the 3 like terms. 3 plus 7 minus 1 is 9. So can I combine these two at all? No, I'm done. This is my answer, and that's what you would type into Math Excel. 9x minus 4. So let's look at, they like to put them in parentheses. Same idea. So I did a couple without parentheses, but they like to put them in parentheses and then make you distribute on some of them as well. So we might look at, I'll do one with distributive. 5, and then let's do an r plus 1. Oops. And we want to add to that negative 8r plus 2. So we might see a problem like this. Now this is super similar to what I just did, but we have a couple extra steps. First of all, we have a 5 in front of this parenthesis. I must distribute, that we learned in the last sections. That means to multiply that 5 by the r and the 1. Well, 5 times r is 5r. 5 times 1 is 5. And then we still have this plus. Now, when I have a parenthesis here and a plus, it's really the same thing as writing that out. If it was a minus, it would be different. And I don't remember if they throw minus at you. Let me look. Plus, 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 plus. The minus makes it like way harder. Nope, the whole next section. Okay, good. I knew we had to do it at some point. So for this section, we don't have to yet. So what am I saying? Okay, I distribute this, then I can combine these, and this parenthesis really wasn't doing anything. There wasn't any number in front. So I have r's here and r's here. What is 5 minus 8 r's? That's negative 3 r's. So those two have been combined. Now 5 plus 2 on our numbers is 7. And that's my final answer because I don't have any more terms and I can't combine those. So I am done. So you might have to distribute and then combine like terms. Let me look. What? They really don't throw much more at you other than some word problems. So what if they say, okay, I'm just going to put this over here so that you can read one. I'm going to do number 7 here. It looks like fun. All right. Oops. Let me correct that there. Okay. Nancy and Bill collect coins. Nancy has X coins. Bill has 5 coins. fewer than 5 times the number of coins Nancy has. Write and simplify an expression for the total number of coins Nancy and Bill have. All right, so what do we, wow, that's a lot, right? Nancy and Bill collect coins. Nancy is X coins. I'm going to, on my paper, you can't see it, I'm going to write X is equal to Nancy's coins, or the amount of coins she has. And Bill has 5 coins fewer than 5 times the number of coins Nancy has. So Bill, I'm going to say is Y, and that's going to be Bill's coins. So we know that Bill will equal Nancy. Bill would have to be 5 coins fewer than the 5 times. So I'm going to have to do 5 times Nancy, right? And then the number, and then we're 5 fewer minus 5. So let me show you where I'm at with writing that out on paper. So, oops, this is a little low because I did it over there. Okay, so Nancy's coins are X's, and I just said Y is Bill's. Basically, it doesn't, we don't really need the Y, but I put it there because it's my habit. So I'm saying, well, Y equals Bill's. Bill's said it's 5 times the amount Nancy had. So I write that as 5X, or 5 times, and then it says Bill has 5 coins fewer. So that's how I did 5 coins fewer. Write and simplify an expression for the total number of coins Nancy and Bill have. So this is just Bill. Nancy is X. So I would have to combine those. X plus 5X minus 5. This is the total of Bill and Nancy. Okay, so these two have like terms. X plus 5X is 6X minus 5. And you can't combine those, so there's your answer. So you might have some word problems where you have to go back and think about how to write it. That one was the hardest one I could see, so I wanted to do it to see. Yeah, that's about as, other than, yeah. Just write out what you see, and remember always, if it's less than, you always have to do it after. And I think you should be good with this section. All right, combine your like terms. Make sure you don't add X's and numbers. Okay.